So this is the first video for chapter 5. And in chapter 5, we're going to start messing around with different types of interest or forces of interest and discount at the same time. So I'll step off screen. Please pause, copy the notes down in your notebook, and then press play and we'll talk through it. Right, so for these early ideas of using varying types and values of interest, discount, and force at the same time, I'm simply going to present two examples, which should give you a really good idea of how to do it. The text has formulas, but they're pointless to memorize based on what you already know. So we present two examples of moving money through time subject to differing rates and forces over differing time periods. So in our first example, we'll have an initial amount of money of $800. During the first year, that money experiences an annual effective interest rate of 5%. During the second year, for some reason, the money is now experiencing a nominal discount rate, convertible quarterly, of 6%. And then during the following 2 years after that, for some reason, there's a constant 3% force of interest in place acting upon the money. And we'd like to know how much is in this fund at the end of 4 years, starting with $800, pushing it through these 4 years at these differing interest rates. So, time value diagram of money starts to become really helpful here. At time 0, I have $800 and I am trying to push it to time 4. For the first year, from 0 to 1, I have an annual effective interest rate of 5%. From time 1 to time 2, during the second year, I have a nominal discount rate convertible quarterly, so D superscript 4 of 6%. And then during the second 2 years, during the last 2 years, from time 2 to time 4, we have a force of interest of 3% in play, right? And the idea is I'm simply going to take the money, $800, and push it forward 1 year with I, take that accumulated value and push it forward the next year with D superscript 4, and then take that accumulated value and push it forward the next 2 years with a constant force of interest, all right? So we know all the formulas to do each one of these pieces. So here's AV1, $800 times 1 plus I to the first power. To get to AV2, I'm going to multiply AV1 by 1 minus D4 over 4 to the negative 4 times 1, pushing forward 1 year at a nominal quarterly discount rate of 6%. So that gets me up to time 2. And then to get from time 2 to time 4, I'm going to multiply by force of interest, a constant force of interest factor for 2 years. So E to the 0.03 times 2 years. And that should get me to time 4. Crank this all out on the calculator, and our $800 has grown to $947.53 in this time. Okay. In example 2, we have a very similar setup. But this time, I'll know the accumulated value and wish to find the present value. So an unknown initial amount of money grows to accumulate to $11,000 at the end of 10 years. And during the 10 years, the investments in force, we have some different experiences. We experience a nominal discount rate convertible semi-annually of 4% for the first 3 years. We then have a nominal interest rate convertible monthly of 6% for the next 5 years. And finally, a constant force of interest of, again, 3% for the last 2 years. And we'd like to know how much money do we begin with? What's the present value? Okay, well, here's my time value diagram again. For the first 3 years, nominal discount rate convertible semi-annually, so D superscript 2 of 4%, first 3 years. Next 5 years, so from time 3 to time 8, I have a nominal interest rate convertible monthly of 6%, so I superscript 12 is equal to 0.06. And then the last 2 years, from time 8 to time 10, I have a constant force of interest, delta 0.03. And so, and I know at time 10, this is all worth $11,000. So I'm going to take this unknown amount X, push it forward 3 years, then 5 years, and then 2 years, and set it equal to $11,000, right? So the accumulated value at time 10, we know is $11,000. And I'm going to achieve this $11,000 by starting with an unknown amount X. And I'll first accumulate it 3 years. So here's my AV3. So I'm going to do 1 minus my semi-annual discount rate divided by 2, my nominal rate divided by 2. raised to the -2 periods in a year for 3 years. So -2 times 3. So that pushes me forward the first 3 years. Then monthly interest takes over. So 1 plus my nominal rate, 0.06 divided by 12 months. And now I have 12 months in a year for 5 years. So I have 60 months worth of this type of growth. That gets me to time 8 years. And then the last 2 years to get to time 10, time 10, I'm going to multiply by the constant force of interest accumulator, e to the 0.03 for 2 years. So I get that massive product. When I multiply the 1 minus 0.04 divided by 2 to the -6, the 1 plus 0.06 divided by 12 to the 60th, and e to the 0.03 times 2, that all comes out to 1.61683209 times the unknown x, and we know it accumulates to 11,000. So I divide the 1.60 thing underneath the 11,000, and I get an x value, an initial amount of $6,803. So if you invest $6,803 and change at time 0, and this type of growth of money occurs during the various time periods specified, then you'd end up with $11,000. So again, absolutely no new formulas here. We're just starting to mush things together, okay?